Hi, welcome to my video on the product rule of logs. The product rule of logs is the log of A times B, A times C base B is equal to the log of A base B plus the log of C base B, where A is greater than 0, C is greater than 0, and the base B is greater than 0 and not 1. Let's look at an example. The log of 1,000, that's understood to be base 10. So 10 to the what power gives you 1,000 is 3. Or we take a calculator and do the log of 1,000, you get a 3. And let's look at this one, the log of 100 plus the log of 10. Again, that's a base 10. So 10 squared is 100, so that's a 2. And this base is 10. So 10 to the what power gives you 10 is 1. So that's equal to 3. Notice both of them are equal to 3. So since both of them are equal to 3, the log of 1,000 is the same as the log of 100 times 10. So that means the log of 100 times 10 is equal to the log of 100 plus the log of 10. Now, notice that the expression, I want to write this out, the expression, the log of 100 times 10, that expression is the log of the product of 110. So that's this one right here, and the expression, the log of 100 plus the log of 10, which is this one, is the sum of the logs, sum of the log of 100 and the log of 10. So, we want to illustrate the log of A times C base B is equal to the log of A base B plus the log of C base B. And this one right here, this is the log of the product. That's the log of the product, and that's equal to the sum of the logs. And note the bases. Bases are equal. So again, I keep repeating this. The log, L-O-G, I better make that a G, not an F. The log of the product is the sum of the logs. And let's do some examples. What about if we have the log of 5x? Well, 5 times x is a product, so that's the log of 5 plus the log of x. And the log of 14 base 3, and 14 can be expressed as a product of 2 times 7 base 3. So that the log of 2 base 3 plus the log of 7 base 3. Because 14 is 2 times 7, so it's the log of 2. Notice the bases are the same, so this is base 3, these are base 3's. And let's reverse it. What about if we have the log of 2 base 7 plus the log of 3 base 7? Well, this is the sum of the logs, so that's the log, base is 7, of the product of 2 times 3. So that's the log of 6 base 7. And another one. What about the log of 6 base 2 plus the log of 5 base 2. Again, the two bases are the same. So that's the log of 6 times 5 base 2. And that's the log of 30 base 2. And the log of 4 base 3 plus the log of 2 base 5. Notice this is a sum, but we can't do it because the two bases are not the same. So right now I can't combine these to make them a single log. Again, the log of the product is the sum of the logs, and the sum of the logs is the log of the product. Just reverse it. So let's do some more examples. Express each as the sum of the logs. Do not use 1 base b. So 15 is the log of 3 times 5. So that's the log of 3 plus the log of 5. The log of a product is the sum of the logs. And again, log 22 is 2 times 11. So that's the log of 2 as a base 3 plus the log of 11 base 3. 22 is 2 times 11. So again, the log of the product is the sum of the logs. Base has got to be the same. And this one, log, that's 7 times x, so that's the log of 7 base 2 plus the log of x base 2. Notice we have 3 here. So this is the log of x base 5 plus the log of y base 5 plus the log of z or z base 5. So this is a product, so we got 3 log of x, log of y, log of z, and they're all base 5s. Let's reverse it. Let's express each as a single log. So this is the sum of the logs. So that's the sum of 2 logs is the log of the product. So that's the log of 8. The sum of 2 logs is the log of the product provided the bases are the same. Notice here, this is base 10 understood. This is base 10. This is base 6. So the sum of 2 logs is the log of the product. 3 times 5. And 3 times 5 makes 15. And right here, we multiply these. So that's the sum of 2 logs, the log of the product. So it's root 6 times root 3. So that's the log of root 6 times root 3 is root 18. And that's the root of 9 times 2. So 2 is the base. So that's a 3 root 2. And the sum of 2 logs is the log of the product. So that's the log of, let's put it right here. Base is 4. Product is x minus 1 times x plus 1. And that's the log of the product. Let's simplify this product of these two binomials. So the base is 4. So that becomes x squared plus x minus 1. So that's the log base 4 of x squared minus 1. Notice the x squared minus 1 has to go in brackets. And the reason is because if I didn't put it in brackets, if I just did this, this is understood to be the log of x squared base 4 subtract 1. So this is by itself, and there's a minus 1. But if I want here, because these two go together, I have to put the x squared minus 1 in a bracket. This is the log of x squared minus 1 base 4. Again, notice the difference. This is the log of x squared base 4 subtract 1. They're totally different. And e, we have the same bases. So we have the base is 7, 7, 7. So that's a 40 times a half times 3/5. So that's the log of, simplify that. 2 into 40 goes 20. 5 into 20 goes 4. So that becomes the log of 12 base 7. Okay, let's do some more examples. The more examples we do, it'll help you understand better. Express each as a single log in simplest form. Now, notice the first rule when we combine logs, simplify logs or solve log equations is do the power rule. So the power rule, we got to go, the 2 goes to the power of 4. And so 4 squared is 16. So now that's the sum of 2 logs. So that's the log of the product. So that's the log of 48. Notice I do the power rule first. So this is the log of, we're having an addition. So the half goes to the power of 9. And the 2 goes to the power of 5. I'm going to simplify that. And this is 9 to the half. The root of 9 has a 3. And 5 squared is 25. And the sum of 2 logs is the log of the product. So the base is 2. So 3 times 5. So that's the log of 15 base 2. Again, the power rule, you should always, any number that's in the front of a log, you should always move it to a power. Always do the power rule first. And C, we have the sum of logs, but we have to move the negative 2 to the power of 1/4, move the 3 to the power of 2, move the 1/3 to the power of 8. So this becomes the log, base is 6, 6, 6. So I got 1/4 to the negative 2. Log, base is 6, that's 2 cubed. Base is 6, I get 1/8 raised to the 1/3. So notice, negative 2 went to the power, the 3 went to the power of 2, 1/3 went to the power. And so so the negative flips the fraction, so that's a 4 squared, so that's a 16. And 2 cubed is 8. And we have 1/3 to the 1/8. That's the cube root of 1/8, which is half, base 6. So we have the sum of all these, so that's 16 times 8 times a half. And so base is 6, so a half of 8 is 4, 16 times 4 is 64. Again, we do the power rule first, simplify each of those expressions, and then we sum of logs is the log of the product. D, again we have a power rule, so 2 goes to the power of 3. So now normally, if you did that, you go 2 to the power of 3, you could write a 9, but I'm putting the 2 here first and then doing the 9 after, just to make sure you understand. So that's the log of 9 base 3. That's the log of x minus 5 base 3. And the sum of 2 logs is the log of the product. So this is 9 times x minus 5, or you could have, this is the log, 9 times x is 9x, 9 times 5 is 45. But again, I could leave it like this, but if I do it like this, I have to put this in brackets because it's all this expression is to the base of 3. And we have a power rule here, so we have a plus, so we do the power rule first, the log of 4 over 3 base 11. And we have base 11, so that's 3 over 2 squared, so the 2 goes to the power, and we work that out, we do the power of base 11, so 3 over 2 squared is 3 squared is 9, 2 squared is 4, so that becomes, let's go over here, this becomes the log of base is 11. So the sum of 2 logs is the log of the product, the bases are the same, so that's 4 over 3 times 9 over 4. And let's see if that's simplified. 4's cancel, 3 and the 9 goes 3, so it's the log of 3 base 11. And F, we have the power rule, where sum of logs is the log of the product. We got to get rid of power first. So it's the log base 2 of 3 to the x plus, this is the log basis 2 is 81 to the x. So the x went to the power of 3, and the 81 went to the power of 3. So that's the log basis 2. So sum of two logs is the log of the product. And we want to keep simplifying this if we can. So this is 3 to the x. 81 is 3 to the 4th to the x. And let's keep going. We got 3 to the x. This is the power of power, so that's 3 to the 4x. And we're multiplying. The sum of two logs is the log of the product, so now we're multiplying here. So we're multiplying, the bases are the same, 3. So x plus 4x is 5x. So that's as a single log. Just a little bit, tiny bit different. Okay, let's do some more. Evaluate each. Evaluate means find. To evaluate is to give a value. So the 2 goes, the sum of two logs, so we move the power first, so it's 2 squared. And 2 square root is a 4. So each log is simplified. The sum of two logs is the log of the product. And the log of the product is the log of 100. And the base is 10. So 10 to the what power gives you 100? 2. So if we did the calculator, the log of 100 would give you 2. And B, we have the log of a product. So the sum of two logs is the log of the product. The bases are 3. So it's a half times 18. So this is the log base 3. Half of 18 is 9. And 3 to the what power gives you 9, and the answer is 2. And again, we have the sum of logs, so we have the log of the product. So this is the log, base is 5, so it's 2/3 times 5 over 2 times 3. The sum of logs is the log of the product. And we're multiplying fractions, so can we cancel? 2's cancel. That's a 3 over 1, so the 3's cancel. So we get the log of, that's a 1, 1, 1, 1, 1. So that's a 5, base is 5. And 5 to the what power gives you 5? The answer is 1. D, we got the sum of logs again. We move this 1/3, it goes 125 to the 1/3 power. And the half goes to the power. 1/4 to the half power. And 125 to the 1/3 is 125. We could do it two ways. Notice we can go cube root of 125, so that's a 5. Or we can do this way. We can go 125 is 5 cubed to the 1/3. 3's cancel, and I get a 5. And I got 1 over 25. And this one right here, that's the square root. Square root of 1/4 is a half. Now they're all simplified. So I'll do 5 times 1 over 25 times 1 over 2. So that's the log. 5 into 25 goes 5, so that's 1 over 10. And this is understood to be a 10. So 10 to the what power gives you 1 over 10? The answer is -1. So just doing a variation of problems to help you understand. Number 5, if the log of 5 base 3 is x and the log of 2 base 3 is y, express each in terms of x and or y. Well, this is a 5 and a 2, so the log of 10 base 3 is the log of 2 times 5. So this is the log of 2 base 3. The log of a product is the sum of the logs. And we have a log 2 base 3. Log 2 base 3 is a y. Log 5 base 3 is an x. So that's y plus x, or you can go x plus y, either or. You can have either or, it doesn't make any difference. And we have a 50. So we need to express 50 in terms of a 5 and a 2. So a 50 becomes a 2 times 25. So that's the log of 2 base 3. And that's a product, so it's the sum of logs. And we have the log of 2 base 3. 25 is a 5 squared. So this is the log of 3 base 2. The 2 goes in front because of the power rule. And move that up here. Log 2 base 3. Log 2 base 3 is a y. Log 5 base 3 is an x. So you could have y plus 2x or 2x plus y, either or. Notice how we're different problems relating, trying to explain or understand the log rules. And we need a 40. So a 40 we need a 2's and 5's. So 40 is 5 times 8. So that's the log of 5. That's the log of a product. So is the sum of the logs. We have a 5, that's okay, because we got log 5 base 3, we had an 8, so we need a 2. So 8 is 2 cubed, and the base is 3. And so we break it right down. We got that. And the power of 2 cubed is 3 log 2 base 3. So the log of 5 base 3 is an x. And the log of 2 base 3 is a y. So you can see, notice you have a 40 and you need 5's and 2's. And we have a 30, and a 30 is the log of 3. We got the log of, let's see what we have here. 30 is 3 times 10. And we got 3 times 10. We got a 2. We got 2 times 15. So that's the log of 2. 15. That's a 2 times 3 times 5. So we broke 30 down into 2 times 15, and 15 is 3 times 5. So that's the log of 2 base 2 is the product of logs. So the product is the sum. The product is the sum. So this is the log of the product, and this is the sum of the logs. We got 2, 3, and 5, all base 2's. What's the log of 2 base 2? That's a 1. 2 to the 1 is 2. And the log of 3 base 2, the log of 3 base 2. Can't do it. If we had a 2 base 3, we might do it, but we can't change it. And the log of 5 base, we had base 3's. Oh, yes, okay. I didn't put my base 3 in there. I thought I made an error. These are 3's. And so I can't change that one. 2 base 3. The log of that's 15 times 2. That's the log of, that's a 1. And what's the log of 5 base 3 is an x. So we can't change this one. But we got an x plus 1. So we can't change the log of 2 base 3. Yes, we can. What am I thinking about? What am I thinking about? The log of 2 base 3 is a y. My mistake. That's a y. So it's an x plus a y plus 1. Just because I made that error at the beginning, not putting the 3 there, then I lost track of it for a while. So this is the log of 2 base 3, which is a y. Log of 3 base 2. Log of 3 base 3 is a 1. Log of 5 base 3 is an x. So that's an x plus y plus 1. Made one little error, and I thought I messed up the question, but I didn't. And the last one to do, if the log of x base 2 is 3, and the log of y base 2 is 4, evaluate. Evaluate means come up with an answer, a value. So the log of a product is the sum of the logs. So the log of the product is the sum of the logs. The log of x base 2 is a 3. The log of y base 2 is a 4. So that becomes a 7. The log of a product is the sum of the logs. So this is the sum of the logs. The log of 4 base 2 is 2 to the power is 4, so it's 2. The log of y base 2, log of y base 2 is a 4, so that's a 6. And we have the log of the product, so we have the log of x to the 4th base 2. The log of y squared base 2. That's the power, so it's the log of x. That's the power, so it's 2 log y base 2. So again, the log of the product is the sum of the logs, and the power 4 moves in front, the power of 2 moves in front. So the log of x base 2, the log of x base 2 is a 3. The log of y base 2 is a 4. So that's a 12 plus an 8. So that ends up to be 20. Now we got a couple more to do. So we got the log of 2. So this is cube root. This is x to the 1/3. And so this is cube root is a 1/3 power, so it's x to the 1/3, and the power moves in front, so this is the log of x base 2, and that's 1/3. Log of x base 2 is a 3, so 1/3 of 3 gives you 1. And one more to do. Let's see, we got to find the value of this one. Well, we have, let's see, we could 4y cubed, and this is x to the negative 2. So what happens, that's x to the negative 2. Now they're all products, base 2. So this is the log of 2, log of 4 base 2, plus the log of y cubed base 2, plus the log of x negative 2 base 2. And we get power, so we leave that. There's a 2 there, there's a 4. Move the power in front. Move your power in front. And the log of 4 base 2, 2 squared is 4, so that's a 2. And the log of y base 2 is a 4. The log of x base 2 is a 3. Multiply first by PEMDAS. And now we add 14 minus 6 is 8. And a lot of people would treat, there's another rule coming up in the next video, and the quotient. But what I did, I didn't have to use that rule. I changed x. This is 1 over x squared. That's 1 over x squared. So that's x to the negative 2. So changing 1 over x squared to x to the negative 2, that allowed me to have all products here. So I'd be able to use the rule that we just practiced. Again, the power rule is very, very important. Always do the power rule first. And if you like my video, click on the like button. Sorry for that little error there I made in number 5. Just messed it up a bit, but we all make mistakes. So if you do make a mistake, learn by it. If you like my video, click the like button. If you want to be a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.